Don't tell me what to do. You're not my boss, Jesse. Try to fix my chair. There we go. See, I'm glad.
So have you read all those books on the shelf behind you?
Definitely the comic books. Yeah, for sure.
Yeah.
No, I have actually. Yeah. I've read most of the manufacturing ones. Yeah, for sure. If you ever want to borrow any, and you see one,
Absolutely.
I'll send you over.
Yeah, that SolidWorks textbook used to be my Bible.
Oh,
in college.
Yeah, right?
Yeah.
Yeah, the SolidWorks, you got to give it up, man. Their documentation's always been amazing.
Yeah.
Absolutely. Yeah, it's awesome. But yeah, a lot of those I keep for reference. When you get older, you start forgetting stuff, and it's like, what was that one thing and that one book? Crap. So.
And now it's just like I use the PDFs version of everything. It's like
so
I don't have the book anymore.
Right? Did you start reading that Algorithms to Live By or whatever?
I did start reading that.
I did too.
How far in are you?
So I skipped around chapters. So I did the one on optimum stopping, and then the one on I got the book in my hand, but I don't want to look. Shit. I forget what it was. Over something. I want to say overclocking, but that wasn't it.
Overclocking?
Overfitting. That's what it was. Overfitting.
Yeah.
Very fucking... super, super interesting. There we go. That was the one that I got out early before we're like super, super duper live. Yeah.
Our producers got it. Thanks, guys.
Thanks, guys. It's the 7-second delay. But it was
I love that first chapter on optimal stopping. It was like the 37% rule.
Right? And it's funny because I tried to explain it to somebody and they were like, well, why wouldn't I go? Thank you. Why wouldn't I look for why wouldn't I go for the most optimum one? Why wouldn't I just hold out? It's like, no, you're looking for the most constant, predictable outcome, right?
It was interesting, though. He says, like, if you do this, you'll get the right answer 37% of the time. But that means, the other 63% of the time, you got the wrong thing.
Right.
It's kind of scary to think about.
Right? Yeah, it's crazy. But yeah, I definitely recommend the chapter on overfitting. It's really, really great. I mean, it's basically like multiple polynomials. Like when you put too many variables into something, how it just absolutely affects basically the curve, right? The average curve. When you put more and more in there, your outcome. So he applies it to some really, really great things about, okay, so I applied it to like looking for a home, right? What's important for you to get a home? Like I want a garage. Okay, well, it's easy, right? Every car's, but when you start adding more variables, your chances of finding that house go down and all this other stuff. It's really, I definitely recommend it.
That's cool.
Yeah.
Going back to the books though, I'm curious, is there like any single, I mean, we spoke about the SolidWorks textbook, which is, like, it was my Bible. Is there any like specific additive like books that you would recommend to someone getting into it as like, okay, this is how you get in on the ground floor?
That's a great question. And, I don't think so. You and I, we've been lucky enough to be around it before it was like super, super big. I don't know that there's enough experts on 3D printing in general, right, to write a book about it. I think somebody from Stratasys could write a book on FDM. I think somebody from whoever, say 3D Systems, could do FDM, or I'm sorry, SLS. But I don't know that there's any. There probably is, but have you seen any books like that?
I haven't seen. Well, I haven't, fair enough, researched many of the subtractive ones. But on the additive side, there was one. It wasn't like super big. It wasn't a very hefty book because you're right. It is so new.
Right.
I feel that's still being matured. It was called Additive Manufacturing Fundamentals.
Wow.
And it covered like all the technologies very briefly.
All right, 15 seconds. Yeah. We'll finish this later.
Yeah. On top. Someone in the chat says cussing is okay. Thanks, TL White. All right. So looks like we are good to go. Thanks everyone in the chat for tuning in. Happy Friday. My name's Noah, and I'm here with Chris. And we have, let's say, a fair amount of manufacturing experience between the two of us, wouldn't you say?
I would say so. Yeah, that's absolutely true. A little bit.
Right. And yeah, so we're going to talk to you guys today about what we would recommend when it comes to specific use cases for additive and subtractive. But before we get too into the weeds with this stuff, let me just PowerPoint open here. We want to give just a basic fundamentals crash course on what is subtractive and what is additive. So simply put, as the name suggests and these graphics show, subtractive is just the idea of shaping a part by removing material from a solid block. Now, there are many different ways to do this: cutting, drilling, milling, grinding, but it's generally great for larger parts with specific material properties, and it's a more traditional way to manufacture components. It's been around since the 1940s. Now, on the complete other side of the spectrum, we have additive manufacturing, which is the idea of shaping a part by adding material as it's needed layer by layer. And there are many different methods to do this depending on your geometry, material, but it's generally great for rapid prototyping, making quick iterations. And even though it's been around since the 1980s, it's generally a newer form of manufacturing that's still being matured. But even though these come from very separate sides of the spectrum, they work together and they really have this great synergy. Chris, you really put it well the other day. Can you tell us a little bit more about that synergy?
Yeah, so I mean, really, when manufacturing historically really has been challenged by availability of tools to get really difficult parts done, like undercuts or things like that. And because of the traditional manufacturing kind of roadblocks, right? This is where additive manufacturing comes in. So with additive manufacturing, as we're going to go through more and more, we get more complexity, things like that. It doesn't necessarily take the place of subtractive, right? It's not one or the other, right? I mean, there's a lot of machines out now, hybrid machines, where you're subtractive and then additive and then subtractive again, taking away and cleaning up the material that was laid down on the part. I think one of the reasons, Noah, and you'll agree that, we're both really excited to do this is because this topic is so fresh right now and so new that, getting this out in the open and starting this conversation is really important, that it's not subtractive or additive, that they really do work together.
Right. So for anyone in the chat, sorry, we put the boxing gloves away. This is not a one versus the other. This is very much working together. But awesome. Thanks for, painting that picture for us, Chris. So let's jump in. We have our first part, and this is our drone frame. It's made out of ABS plastic, 4 inches by 4 inches length and width, only an inch tall. Customer wants 10 of them, and the defining characteristics are lightweight, durability, and it needs to be inexpensive. So before we jump into it, I just want to preface all the parts we go through today. You can subtractive manufacture the ones we would recommend using additive for. You could, and vice versa. You could injection mold these. You could whittle them with a stick, as one of our producers pointed out. But this is just our recommendations, for this specific criteria and the additive and subtractive requirements. So let us know in the chat how you would make this, if you would go the additive route or the subtractive route. And we're going to reveal the answer here in a couple seconds. That's right. Again, let us know in the chat.
So this is a really interesting model also, Noah. Yeah. It looks really simple, but then really when you look at it a little bit closer, it becomes a lot more complex, and I'm looking forward to seeing how many people go which way on how do they make this.
Absolutely. And for this one, we're going to go with additive. And there's a couple reasons why you would go additive with this part. Going down the line, when it comes to the material size and quantity, you could go either ways. They could be subtractive characteristics. But if you're looking to reduce weight, additive gives you the unique opportunity to get those hollow infills. And this quality, CNC machines, subtractive manufacturing machines, they can't replicate because there's no hole for the drill head to enter an enclosed surface. But beyond that, not only can you make hollow infill, but you could actually control the infill based on your specific needs. So you can make a part completely hollow to reduce as much weight as possible, or you can create specific infill patterns related to, let's say, strength. So there's also many softwares now that can let you do a gradient infill to change how dense different parts of a component are. So let's say the cylindrical parts of this drone that protect the propeller, let's say they take a beating more so than other parts. So you can manufacture this with additive manufacturing. So those cylinders have 100% infill, super dense, super strong, and the rest, like these bars or the middle part holding the PCB board, for example, is only maybe 5 or 10% infill. So you're saving weight, and essentially you're saving material and money as well. And finally, for economic purposes, cost-saving production, additive is a great choice here because if we hop into XDesign quick, I could get our drone up, we could see how if we were to subtractive manufacture this, a traditional CNC machine, and Chris, feel free to chime in, it would only be able to cut down from the top. So this is only the geometry we would have access to if we're cutting. But if we look from the side, there's a bunch of geometry here, like the underneath of this bar and this little crevice here that we wouldn't be able to get to if we were cutting straight from the top angle. So this is a great example of how if you were to CNC this, you would either have to use a multi-axis CNC or you'd have to take this part out, flip it over to get the other side. So for those reasons, and let me know if I left anything out there, Chris.
Yeah, no, for sure. So I was looking in the chat and somebody was talking about injection molding and things like that. And yeah, you could definitely injection mold this. The amount of slides would be ridiculous, right? Because we had slides on all 4 sides and in the middle. Yeah, for sure. There's undercuts on this part that make it pretty impossible to just subtractive, to make these on a table out of plastic or aluminum or whatever, because of those undercuts. I mean, of course, I shouldn't say impossible, right? Anything's possible. I think we've all in the shop made things that people thought were impossible, but this is a great example of additive, Noah, for sure.
Thanks. So, yeah, so those are the reasons why we would do additive for this one. On to our next one, though, our blow molds.
Yeah.
So this is a tool steel material, pretty large part, 16 by 10 by 6 inches. Customer only wants one of them. And defining characteristics are a smooth mold surface and wear resistance. So let us know in the chat, what are you thinking for this, additive or subtractive?
Yeah, just throw it in the chat really quick and we'll see. But these blow molds are great. This is actually, this kind of mold is something that I used to use for demos, CAD and CAM demos, like way back in the day. And everybody was all impressed with the bottle mold and the blow mold. It was really fun to bring it back and talk about 3D printing it or machining it. It was great.
Awesome. So let's go ahead and reveal the answer here.
You got it.
It is subtractive. Chris, can you tell us about this one?
Yeah, so this one might seem obvious because it's like a big block, right? But, more and more, as Noah was saying, with the the inside structure and the fill options for 3D printing, you could definitely do a mold core out of this. Now, for this one, just because of the size, you're looking at 16 by 10 by 6. That would really stretch the build volume of a metal 3D printer.
Yeah.
And that being said, doing this in 2 parts is probably be disastrous. Also, there's another big thing is surface finish. You're probably going to have to machine the cavity of this to get that shiny surface finish. If you did print this, you'd have to do it post. Although we only need one of these, which would really kind of lend itself to 3D printing. Because of the use, because of the forces on this, definitely subtractive for sure.
Awesome. Yeah, and thanks to those in the chat who said subtractive. Kudos to you. Our next part, we got a microphone stand. Chris, can you tell us about this one?
Yeah, so this is great. This is actually my microphone stand that I'm using right now. It's actually kind of a mix of stainless steel and tool steel on the back. The customer called, they said they want 500 of these. It's a prototype run, right? So and here's the big things, right? It has to have a heavy base because it needs to hold it, and it needs to be sturdy but lightweight, right? That bracket. So what do you guys think? So it's got to be heavy, right? It's got to be sturdy, and we need 500 of them.
Yeah, and this is a good one. I think you can definitely additively manufacture this. You can definitely subtractively additive manufacture this.
Yeah.
It could go either way. So the defining characteristics here really play a part in which way we would recommend.
Right.
So
yeah, I mean, one of the biggest things too is, one of the things we talk about subtractive versus additive. But I think in the subtractive realm, we could also talk about castings. Yeah. Right, because at some point we have to machine that cast. Although there you go, Noah. There's another great live episode using 3D printing for castings. But for right now, just talking about this one, casting at least the top part and attach at the bottom might be a good way to do it. But yeah, let's see what they said in the. Let's reveal like how we do it.
There we go. And this is a subtractive one, yeah.
Yeah. So the big thing here, guys, is and people, sorry, guys and ladies, is the heavy base, right? That's the problem. So if we could add stuff to the base, but we're talking 500 of them. So if we were to print them hollow and fill them, say, with lead shot or sand or something, first of all, what a mess. Second of all, it's expensive, right? You're talking about materials to put in there, people that do it, things like that. When you add all of that for a 3D print, it really makes sense to go ahead and make these individually using subtractive. Without a doubt. And again, maybe the brace, now that I look at that, would probably be cast and then attached for sure.
Yeah. And we were definitely saying with that heavy base as well, even if you printed it with 100% infill at the bottom, it's still, I don't think would be heavy enough to handle, like a Yeti microphone or something of that nature. So definitely subtractive for this one.
Yeah, for sure.
All right, let's move on to our next one. We have our prototype helmet. This is a multi-material part. It's got rigid ABS outer shell with a rubber TPU inner shell. It's around 11 by 8 by 6.5 inches. The quantity is 10, but the customer wants different sizes and colors. And defining characteristics are multi-material, multicolor, and they want to use this for visual and fit testing. So let us know quickly in the chat if you're thinking additive or subtractive. And we'll reveal the answer here in a sec. Drum roll, please. We got additive manufacturing. And this is an important one because it points out a really important defining characteristic that makes additive different from subtractive. In subtractive manufacturing, you have your block or material that you're cutting away from, and it's usually a singular color or material. Whereas in additive, you have the ability to deposit colors and materials in specific areas. So this is commonly used to differentiate support material from model material, where you could break away supports for overhanging angles. But you could also use this to differentiate different parts of the same model, where we can print a flexible inner shell and a rigid outer shell. Some additive technologies even take this further, and instead of just using separate nozzles to deposit separate materials, they can mix those materials and colors as well. So you could get qualities of both materials in one. So this can be done to mix yellow and blue to create green, as you see in this example, but you could also mix flexible and rigid materials to get a material with different degrees of hardness, which is something really interesting that's going on and further being researched now. And finally, this capability would be great for this case economically, because if the customer is interested in running several tests for, let's say, visual fit testing, they need to make a lot of iterations. It's likely they're going to need to make variations, different colors, different sizes. And with subtractive, you'd have to buy each of those materials and colors to cut your part, where in additive, you can mix those base colors, mix those materials until you find a winning combination and a winning prototype. So you could very much just stick with the materials you need and mix and match them till you get what you want, as opposed to buying exactly what you need.
Yeah, no, you're absolutely right. No, and I think, those points that you brought up are great, especially when we talk about iterative design cycles. Back in the day, back in my day, right? I sound so old, but we're talking about rim molding, silicone molds, but definitely maybe prototype injection mold when you get further down the iteration cycle. But this is something that could be done on a CNC machine. I've done grill hoods, if you talk about weird size things, but with the introduction of 3D printing into, again, that iterative design cycle, this is a perfect example of being able to have that flexibility until you're ready to make that hard mold, right? Yeah. Absolutely.
And shout out to the chat. We have our man Mike Sandy who got it right. Printing is the way to go. We also have
everybody's
Eric
doing great.
Printing. Yep. Thanks, guys. And
Eric, Hone, everybody. You guys are doing great.
So this is an interesting one. This is a hip joint. Material is titanium. Size is over a foot in length, 5 inches wide, 2.5 inches thick. The customer only wants one of them, and defining characteristics are biocompatible material and a complex lattice structure geometry. So quickly let us know in the chat, additive or subtractive, and we'll reveal the answer in a second. I have to say, this is my favorite one, Chris.
Yeah, this one's pretty awesome.
This is a really interesting one.
Yeah. So, this one's interesting. Everybody, when Noah and I were getting ready for this, believe it or not, we practice, right? This isn't just the first time we've done this, but we were talking about this, and, we were talking about how these used to be made. Yeah. And it's crazy. Noah's going to explain it, and then we'll go in a little bit about why additive is above and beyond the reason for this. So yeah, go for it.
Yeah, like you said, this is a really interesting one because traditionally, this is additive, by the way, and it's because of really that lattice structure. But typically, these hip replacements were made with subtractive manufacturing. And what it really comes down to, why this is now becoming an additively manufactured part, is that lattice structure, where you have this complex overlapping geometry that drill heads or milling heads just can't get into. And to give you a stat, traditionally manufactured hip replacements are still widely used, still created and used today, but a study did show that 20% had to be replaced within 25 years of those traditionally made hips. So additive manufacturing is really there to kind of decrease those chances of having to replace or redo a serious surgery like a hip replacement.
Yeah, and this is all because I'm sorry, go ahead. Because that lattice structure, the bone is actually able to go in and grow into that and through that. And really, no, that's one of the, as we were talking before, sorry to interrupt, it's just really cool model. Is one of the reasons they need to be replaced. I mean, they're titanium, right? So they're not going to rust. The reason is they start to loosen up, and after 25 years of doing whatever you want. And way back when, I think some of us may remember, if you broke your hip when you were in your 20s or 30s, you had to wait till you were 50 or 60 to get a replacement because you just have to get 2 of them. So yeah, it's pretty neat.
Yeah, you beat me to the punch.
Sorry.
No, you're perfect. Osseointegration is what I was going to say. That connection between the bone and the artificial implant. That lattice structure allows for a better bond between those two. So when you put this in, the bone will literally grow around this implant, and it's not going anywhere. But exactly like you said, definitely something exciting, I think, where additive is being used in the medical community. All right, next up we have this hand pliers tool. The material is nylon. Size is 4.5 by 5 by 3/4 inches. Customer wants 200 of them, and defining characteristics are quick turnaround, so fast production, and they need to be durable. So let us know quickly in the chat, what are you thinking, subtractive or additive for this one? And we'll go ahead and...
Yeah, this one was fun. So this one Noah brought in to the presentation, and the first time I saw it, I thought, okay, that's unfair. Like, it's going to be printing. But the more I thought of it, I was like, I could totally machine that, man. It's only like, what, 1, 2, 3, 4 parts, man. Yeah. But there's something about it. We'll talk about it. We'll talk about it afterwards that I actually thought about last night. Not to throw a curveball at you, but yeah, go for it.
No, in fact, we'll even make it a little bit easier on the audience. We'll bring up the 3D model in XDesign so they have a good idea of this part, how it moves, and we'll even give them a section view. Let's see here. So we could go through our part quickly so you can see how the internals work and such. So, jump back to our presentation. Having seen that, we're going to go with additive. So why is this additive? And the main reason is movable assemblies. So if we're looking to do a quick turnaround time, fast production, we don't want to have to assemble these pliers together. And Chris is 100% right. You can absolutely subtractively create these parts. Thing is, you're going to have to assemble those parts together once you finish making them. Where in additive, you can print support between these parts, and when this part comes out of the bed, you can just blow away that support material, and your part is then free to move. Another reason why we would go with additive, especially when you have this moving assembly, is multi-part production. Now, this is a strength that can go with additive or subtractive, producing many parts in a quick time frame. But if you're going with additive, you get to exercise a unique capability, which is Z-stacking, or we call it nesting. And basically, if you're using a powder technology, like in this video here, we're using SLS, or you're using binder jetting, the parts as you make them are suspended in this volume of powder. So they could literally sit on top of each other, and when you remove them, you don't have to worry about compromising any of the parts below them or above them. So unlike material extrusion, which you may be familiar with, it's like the most popular desktop form of additive manufacturing. In that case, you can only use the entire build volume in the X and Y. It's not advised to print support that you have to break away and then print another model and break away support on top of that, because you're going to get some poor surface finishes on the bottom of your parts. Here, you don't have to worry about breaking any way material. You could fill the entire build volume in the X, Y, and Z.
Yeah, that's basically absolutely right. You know, I think manufacturing-wise, if I was to break this into those 4 pieces, honestly, I maybe the production time, because it's 200, because it's so it's a 2D or 2-axis machine, I may be able to maybe get close to the production time, but it's the assembly that adds to it, right? Because I'd still have to put either pins, drive pins, whatever kind of assembly I end up doing on this. Whereas 3D printing, it's not just the cost of making it or what's easier to make or anything like that. It's the post processing. What do I need to do to this part afterwards? Does it make sense? And this is a really great example. Again, no, we're killing it with ideas for new lives, but this is a great example of design for print or design for subtractive, right? So, you know, when you get the design for intent, it really starts to get important and really starts to show your time savings and cost savings for sure.
Absolutely. Yeah, no, that's a great point. I definitely have that one on my list. Designed for additive or designed for subtractive. Changing your model so it's easier to produce is a topic we could talk about for forever.
Forever. Yeah.
Forever. Yeah. But next up, we have this bracket. So this is a bracket made out of aluminum. It may look familiar to some of you in the chat. We'll see. Its size is 6.8 by 4 by 2.5 inches. Customer wants 400 of them, and defining characteristics are lightweight and durable. So let us know.
It's starting to get tougher, guys.
Subtractive. It is.
That's right. It's starting to get tougher. What do you think? So this one was a fun one too that we talked about. You know, as an example, it is pretty basic, but when we look at this for subtractive, there is, you know, it's basically a 2D part, but there is that side on. There's a side op where you have to do that big hole going through. You know, there's a lot of things to consider, you know, stability of the print, things like that. So let's see what everybody comes up with.
All right. So I'll go ahead and reveal the answer here. And it's subtractive.
Definitely.
Chris, can you tell us why?
Yeah, so, you know, it's really basic 2D geometry. If I was going to machine this, I could get, depending on the size, so it's 2.5 inches high, I could definitely get a plate, secure it down, you know, machine these all from the top, you know, cut them out, and then do a side op for that side. It'd be a pretty fast thing we can do in multiples. It'd be a fast machine time depending on how many I could fit. Absolutely. You know, somebody said aluminum, and that's absolutely right. So if this part's made out of aluminum, it'd be really fast and easy to machine. So this one's going to be 2x, or I'm sorry, it's 2D. Sorry, this one's going to be subtractive.
And yeah, we got some great answers in the chat. Machine it.
Did.
Aluminum, subtractive. Awesome. Thanks, guys.
So what would make this not subtractive, Noah?
Well, I'm glad you asked. So this is the same bracket in a sense. Same material, roughly the same size, same quantity, and the defining characteristics are the same in lightweight and durability, but this time we have a complex geometry. In fact, it's even overlapping in some cases. Mm-hmm. So I think our audience should be able to guess. We changed this a little bit. So it's not going to be subtractive this time. It's going to be additive manufacturing.
For sure.
And weight reduction and free complexity go hand in hand when it comes to why this part would be additively manufactured. And it comes down to the same principle, which is generative design. And for those that aren't familiar with it, it's the idea of just optimizing a 3D model based on its loads and constraints. So, just like in the last example Chris spoke about, you could see the same 2 vertical holes at the top and the same 4 horizontal holes at the bottom. Those are our constraints, so they cannot be compromised within this model. However, the geometry holding together those holes is obviously very, very different. And that's because generative design was used to analyze the loads on this part, which way would be pushed, pulled, twisted, whatever. And it recommended this geometry to maximize strength and reduce weight as much as possible, because those were our constraints. And when you use this principle to create this shape, it'll often dictate your production method. Yes, generative design parts can absolutely be CNC'd. Mm-hmm. But typically, when you have those organic curves and those tight crevices, they lend itself to 3D printing, and that's because AM uses the concept of free complexity. And you can see it in this graph here. It's a really interesting concept that basically explains the more complex your part gets, it doesn't necessarily mean it gets more expensive. Whereas in subtractive, typically the case is the more complex it gets, the more you're going to have to pay, the more machine time you're going to have to use, and so on.
If I could jump in just really quick.
Absolutely,
so
yeah.
We joked about taking the gloves off, but this is probably the only thing that Noah and I actually had a little bit of a heated discussion about, because I'm like, no way, man, that's impossible. So we really thought about it, but it's true. We couldn't come up, and if somebody in the chat could come up with a part that as you add complexity to it, it actually makes more sense to CNC it. Like we couldn't figure it out. Like we couldn't find one. So that was actually a really great conversation that Noah and I had while prepping this. This was a really great graph. Thanks for throwing that in there, Noah.
Absolutely. Yeah, you had mentioned like a fully flat part, maybe that didn't have any like complex 3D structures. And I guess it technically could go either way. But yeah, it's hard to find a part that would really expose the free complexity that AM offers for subtractive. So yeah, additive for this one. And next is onto our injection mold core. So this is another part made out of aluminum. Size is 8.5 by 8 by 4.5 inches. Customer only wants 2 of them. And the defining characteristics are low run injection mold, coolant ports on the side, and smooth mold surface. Now, before you guess on this one, just take some time to analyze the part and let us know what you think.
Yeah, for sure. It looks pretty simple to me, Noah. I don't know.
So have you ever like made a part similar to this?
I have actually. You know, I did my apprenticeship in injection mold making, so some of our projects were making mold cores very similar to this. And it took a long time. Yeah, but we did. I mean, there was definitely a little bit more complex, but yeah, I've definitely made some like this. But yeah. Awesome.
All right, well, I'll go ahead and reveal the answer here. It is subtractive. Can you tell us why?
So looking at this right here, right? So we're saying subtractive. Looking at it, just looking at this, I'd be like, this is great, right? It's a 2-axis. The majority of it is 2x with maybe a little bit of with a draft, which I could probably do with an angle cutter. Going around the top, there's a little 3-axis. If I had a rounding over cutter, maybe with an angle. Yeah, for sure. I mean, this is just so basic. I would definitely machine this. If I just saw it like this, I would say, yeah, definitely. Let's go ahead and machine it.
All right, but there may be something more to this part.
What?
Let's take a look. So it's got some internal cooling channels, which adds a factor to this that maybe makes it a bit more complicated. Mm-hmm. So Can you tell us why?
Yeah, so this is something that's really, really becoming popular, injection molding and printing, and it's called conformal cooling. So instead of old school cooling lines just being like straight drills that kind of ran into each other, now we're able to print these mold cores with these more complex channels for cooling channels. Somebody actually, and I want to bring this up just as a side note. So this really brings it into hybrid, which I'll get to in a second. But Noah and I were talking about how cylindrical those channels are going to be when you print it. And somebody in the chat asked that, like, how do you compensate for concentricity or circularity in printing? There's ways to do it. For sure. There's a couple ways. There's settings on the printers. There's ways to modify your model. Generally speaking, instead of making a whole circular, you'll make it a little teardrop shape. That's one way I've seen done. But here it doesn't matter, right? Because they're coolant channels. So the shape, the actual cross section of those doesn't really make a difference. So going why it's hybrid, obviously you need to print it to get those channels in, but we also need that smooth mold finish, right? So we can't just print it. What we'd end up doing is printing it and then doing a post-op on the mill to get that really nice surface finish on it, turn it on its side, do a couple NPT taps for the coolant inlets, and that's it. So this was actually a tricky one. It was actually hybrid, for sure.
Yeah, and I love that we, included that coolant because, as you mentioned, that is growing in the manufacturing community, making those coolant parts. And that teardrop shape you had mentioned, that was something big, when I was in school. When I've seen these parts made, they try to do that teardrop shape because if you're producing this with a powder technology, let's say SLM or direct metal laser sintering, those top layers of your circle can tend to cave in. And when you have that teardrop shape, they meet at this sharp point and they're less likely to cave in. So I thought that was an interesting way that they got around some of those complex manufacturing challenges. So those are the parts we wanted to run through. But we do have a couple extra minutes here, and I'd like to show something that I didn't get to before. So let me bring up my window of X Design. Now this is our generative design bracket. And you can see it has that complex overlapping structure. We would definitely additively manufacture this instead of subtractive because it'd be very difficult for our drill head to get in here. But let's say we actually want to prepare this for a 3D printing job. Well, under our tools here, we have our Print 3D feature, and we could actually select what's going to be our bottom face here. And now we can visualize our part in our visual print bed. So this is just a feature I wanted to plug a little bit for our software when it comes to additive and preparing your part. And you could even, let's say, visualize the support you'll need, because a big part that Chris and I have spoken about is these undercuts. How are you going to manufacture those with a CNC machine? Well, if you're manufacturing them additively, you can visualize exactly where you're going to need that support and insert a specific overhang angle, depending on the capability of your machine. So just a quick plug, I wanted to add a quick capability because we get a lot of questions about that. Okay, I have my part, but how do I prepare it for manufacturing and such? So just a quick plug I wanted to add about that. Is there anything else, subtractively speaking, that you would add on any of these parts, Chris? Oh, I think we may have lost your audio.
Sorry, I was answering the chat and I didn't want to hear you guys have everybody hear the tic-tac. So, no, I mean, I think we hit them all. Bringing that up in X Design is really great. We've got some really great CAM tools, so keep an eye out for that with Manufacturing Live. And maybe we'll kind of get some in Design Live too, where we can really utilize these models inside of that 3D Experience platform for subtractive manufacturing. Also, Noah and I were talking about, the printing setups and stuff in the platform. It's amazing, and it's only getting better. And we're really excited about it for sure.
Absolutely. One thing I've seen that's really interesting when it comes to manufacturing these parts is we're at a point now where we have machines that can manufacture some of the most complicated geometries some of the most complicated multi-material parts, but there's not always a software that tells the machine how to print it or how to subtractively manufacture it. So that's some of the problems that we're trying to, solve here with our software. And it's something that we're always constantly asking in our heads. All right, we have this beautiful thing, but how do we bring it to life? So those are all the parts we had.
Yeah.
If you have any questions, please let us know in the chat.
For sure.
And we'll get to them as quickly. Also, if there's anything that we don't get to, comment on our video, and we will get back to all those comments and all those questions.
Yeah. So one thing I wanted to mention too is we just briefly mentioned generative design, Noah, and I know that we do have that capability in our platform. Is that true?
We do have it in XDesign, yes. Yep.
There you go. So what do I know? I'm a manufacturing guy, but for all you design guys out there, definitely check that out because it's definitely interesting.
Yeah, that's a great point as well. So I think that is all we have.
Yeah,
for
I think
today,
that's it. How about don't we have something coming up in February or something?
I don't know, something small. I don't think. I think it's a big deal. But yes, great point. We have. Well, why don't you tell us about it?
So we have 3D Experience World, for those that you don't know, coming on up in Nashville. So those of you that don't know, it's an amazing gathering of everybody that uses, loves, utilizes, wants to utilize more, wants to talk about pretty much all the SolidWorks products, the 3D Experience platform in general, everything. There's great breakout sessions. The main stage is just amazing. I mean, it's for those of you that have never been to to a world event like a SolidWorks World, a 3D Experience World, it's definitely worth it. Registration. So you guys can go to 3dexperienceworld.com and register there. We'll also put a link in the chat if you'd like to register there. Both Noah and I will be there. I will be on the shop floor at the 3D Experience World running a milling machine, making some pretty cool stuff. So, keep tuned in, and we'll talk more about that as it gets closer.
Absolutely. And it'll be my first time at World. I don't know about you, so I'm super excited. And for anyone in the chat, you'll be able to meet us, meet the team, give us all your manufacturing questions. We did get one from our man Sean O'Neill, additive or subtractive on the shop floor.
Let's bring it, man. That's the boxing gloves, man. We're going to do an octagon in the middle of the shop floor for that one. I don't know. But, yeah, thank you. Oh, like and subscribe, right? As we almost missed that, being engineers. Everybody, this is one of our favorite things to do for you guys. We love getting out. We love talking to you. We love getting interaction through the chat and stuff like that. Please like and subscribe. You'll get some notifications when new ones come up. You can see the old ones, all that other stuff. So please like and subscribe. We'd really appreciate it.
Yeah, thanks again, everyone, for tuning in. And have a great rest of your weekend.
Thank you, everyone.